Okay, so welcome back to the deep dive. And today we're really diving into something that sounds like it's straight out of science fiction, right? It's the whole quantum computing and AI thing, you know how they're all tangled up together.
Yeah.
And you're here because you're the kind of person who wants to get right to the heart of it all, right? You want to know what's really going on and what it all means. So we've been digging through some really interesting stuff.
Right.
And we're going to try to bring you the key takeaways, right? The stuff that really matters.
Absolutely.
And for this one, we've been mainly focusing on this discussion with Fernando Dominguez-Pinuaga from Sandbox AQ.
Okay.
And the main thing we're going to try to do here is we want to get past all the hype, right? You hear so much about quantum this, quantum that.
Yeah.
What's the reality? What's actually happening with quantum computing? And how is AI playing a role in all this? And what's it all going to mean for, businesses and for us regular folks in the years to come?
Right. Yeah, it's interesting because I think a lot of times the first time that people encounter quantum physics is through science fiction. Right?
Oh, yeah, for
You
sure.
see shows like Devs, and they present it as like this mystical force, almost like magic.
Right.
But the reality is quantum mechanics are just the fundamental rules of the universe at the atomic level.
Right.
It's not some sort of distant fantasy. It's the basis for a lot of the technology that we use every day, from photonics, transistors, GPS, even MRI machines.
Okay, so it's not magic, but it is kind of like the bedrock, the foundation of so much of our technology today,
Yeah,
right?
absolutely.
And now what's really changing things up is that AI is getting more powerful, and that's really accelerating the development of quantum computers and also helping us figure out what we can actually do with them.
Yeah, exactly. AI is becoming sort of like the key to unlocking the potential of quantum mechanics and helping us see what are the most promising areas where we can actually apply it.
Okay, so when it comes to quantum computers, when are we actually going to see them doing things that matter, that have an impact on businesses and people's daily lives? Fernando seems to think that around 2028 to 2030, that's when we might start seeing what he calls viable or business useful quantum computers.
Right, right. There's a lot of excitement around that sort of near-term future.
Yeah.
But it's important to remember that the quantum computers that we have today are still basically in the research phase. They're very error-prone, so that really limits their widespread use at this point.
Right.
You can kind of think of them like super powerful calculators, but they still make a lot of mistakes.
I see. I see.
So we're not quite there yet, but the progress is happening very rapidly.
Yeah, that makes sense. That makes sense. And this kind of brings us to this whole debate about quantum supremacy versus actually solving real world problems, right? I
Yeah.
mean, we all remember back in 2019 when Google made that big announcement about their Sycamore chip. Doing that calculation in like 200 seconds, that would take a supercomputer 10,000 years or something like that. I
Yeah.
mean, that sounds like a huge leap forward.
Absolutely. It was a landmark demonstration of the raw power that quantum computing has.
Yeah.
But it's important to note that the problem that the Sycamore chip solved was very specific. It was like this very specialized mathematical problem, kind of designed to showcase the speed advantage.
Yeah.
It wasn't actually solving any real-world problems that humans were facing at that time.
So it was more like proving a concept than actually, giving us a solution that we could use right away.
Exactly.
And it's really interesting that Google even offered a $5 million prize for anyone who could use a quantum computer to solve a truly useful problem, right? I mean, that kind of highlights how much work still needs to be done.
Yeah, absolutely. It really underscores the gap that still exists between the potential of quantum computing
Yeah.
and the actual practical application to real-world problems.
I see. I see.
But, it's likely that in the future we'll see a sort of hybrid approach, right? Where we have CPUs and GPUs working together with these QPUs,
Right.
and we'll break down problems into their different parts. And each part will be handled by the type of processor that's best suited for the job.
That makes a lot of sense. That makes a lot of sense. So are there any particular types of problems where you think quantum computers are really going to excel?
Oh, yeah, absolutely. Fernando talks about things like optimization problems.
Mhm.
So think about optimizing logistics for a huge supply chain
Yeah.
or solving that classic traveling salesman problem in a really efficient way.
Right.
And also cryptography, that's another area where quantum computers have the potential to really shake things up.
Okay. Okay. So speaking of shaking things up, let's talk about Sandbox AQ, right? This is
Okay.
the company that Fernando is a part of.
Yeah.
And it's got this really interesting origin story. It started out in Google X, that's their moonshot factory.
Yeah.
And then it spun out into its own company in 2022, and they just got this massive $300 million funding round, with some really big names like Mark Benioff, Eric Schmidt, Jan LeCun.
Right.
I mean, when you see that kind of backing, they're onto something, right?
Yeah, for sure. It definitely raises eyebrows.
Yeah, and the thing is, the AQ in Sandbox AQ, it's not just a random name.
Right.
It stands for artificial quantum. And their whole vision, what they've been working on for over 7 years now, is that this idea of combining artificial intelligence with quantum technologies.
Absolutely. And, a key part of their work is what they call large quantitative models,
Yeah, or
LQMs. And
QMs.
these are AI models that go beyond just crunching numbers and data.
Mm.
They actually incorporate the fundamental laws of nature, like mathematical, physical, biological, chemical, even quantum physics principles.
Okay.
It's built into the structure of the model itself.
So it's like they're teaching the AI the actual laws of physics.
Exactly. Yeah, it's not just about statistical probabilities. It's about understanding the underlying equations that govern the universe.
Wow. So how is that different from like the large language models, the LLMs that we're hearing so much about?
Right. Well, LLMs are really good at processing text, generating text, based on patterns and probabilities.
Yeah.
But LQMs are different. They're built to solve problems based on the actual equations of the universe.
I see.
Fernando gives this great example with like 2 plus 2. An LM might predict 4 because it's seen that pattern a million times.
Right.
But an LQM would actually perform the mathematical operation of addition
Okay.
to get to the answer. So it's a fundamentally different way of understanding.
I see. So it's not just pattern matching. It's actually like understanding the underlying principles, right?
Exactly.
And that's how they avoid those weird hallucinations that we sometimes see with LLMs, right?
Right. Yeah. That's a big advantage of LQMs. They're less prone to making those kinds of mistakes because they're grounded in the actual laws of physics.
That's fascinating. And is Sandbox AQ the only company that's really pursuing this approach?
Well, Fernando points out that there aren't a lot of direct competitors working on this specific combination of AI and quantum physics in the same way that they are.
Right.
Obviously the big tech companies have their own internal research going on.
Sure.
But Sandbox AQ seems to be kind of carving out their own niche in this
Ah.
space.
And it's interesting because it seems like this whole think big mentality is just baked into their DNA from their time at Google X.
Oh, yeah, absolutely. The whole culture at X is about focusing on these massive global problems, trying to solve things that could impact billions of people.
Right.
It's about finding those problems that if you can solve them, it's a game changer for the entire world.
Yeah, he really emphasized that billion number, didn't he?
He did. Yeah,
Yeah.
he's really passionate about that.
Yeah, and he used Google Maps as an example, right?
Yeah. Google Maps was this massive undertaking, took years to develop,
Mm-hmm.
no clear path to profit in the beginning. But the idea was that if they could create something truly valuable, a comprehensive map of the world, the monetization would come later.
Right. And at the time, it sounded crazy, right? Driving around with cameras on cars, mapping every single street.
Yeah, a lot of people thought it was a crazy idea, but, look at it now.
Yeah, exactly. Exactly. And it seems like that same kind of long-term vision is also behind projects like Project Loon, trying to deliver internet access via balloons.
Right.
And the early work on self-driving cars that eventually led to Waymo.
Yeah. And even if Waymo doesn't end up being the top dog in the self-driving car market,
Right.
the work that they did really pushed the whole industry forward and has the potential to make our roads much safer and save lives.
Yeah. Yeah. I mean, even if they're not the ones who ultimately win, they've kind of paved the way for everybody else.
Absolutely.
And it's fascinating how Sandbox AQ itself came out of this think big culture, right? I mean, it was Sergey Brin himself, Google's co-founder, who really pushed for this.
Yeah, initially he even called it Sergey Sandbox. That's funny. And he brought in all these top professors to teach the software engineers about advanced science and mathematics.
Wow.
The goal was to give them this deep understanding of these really complex fields so they could then go and apply that knowledge to real-world problems.
That's amazing. And so what kinds of things did they start exploring?
Well, they went into all sorts of different areas of quantum technologies, things like advanced sensing, quantum simulation of materials, cybersecurity, quantum communications, even the groundwork for a future quantum internet.
Wow.
The underlying idea was always, how can we combine these quantum capabilities with artificial intelligence to really amplify their impact.
So they were thinking about the synergy between these two fields from the very beginning.
Absolutely. That was a core part of their vision from day one.
So this brings us to what Fernando calls physical AI, which really aligns with a lot of the ideas that NVIDIA's CEO Jensen Huang has been talking about.
Right. It's about AI that isn't just stuck in the digital world. It's AI that interacts with and shapes the physical world. And robotics and quantum physics are going to be key parts of this.
So it's like AI that can actually do things in the real world.
Exactly. Yeah, it's about AI that can build things, move things, create things in the physical world.
And we're already seeing this happening, right? Like Sandbox IQ is working with NVIDIA. Their engineers are collaborating to get those powerful GPUs from NVIDIA to run those complex quantum computing equations and to speed up the training and development of those large quantitative models.
Absolutely, yeah. That kind of co-engineering is really essential to bridging that gap between the theoretical models and the actual practical applications.
So it's like they're building the hardware and software together to make this physical AI a reality.
Right, yeah. It's all about making those models work in the real world, not just on paper.
So in a way, physical AI is about taking the insights from those LQMs and applying them to things like robots, right?
Exactly. Yeah, robots that can do really complex tasks in the real world.
And I guess that's where LLMs, those large language models, I kind of fall short, right? I mean, they're great at understanding and generating text.
Right.
But when it comes to like core industrial applications, things like energy, oil and gas, finance, automotive, aerospace.
Yeah, those are the areas where you really need that precise quantitative understanding that LQMs provide.
Right, right. Because those industries are all about interacting with the physical world.
Exactly. Yeah. And Fernando highlights some of the work that they're doing. Like they're working with the Army to develop new lightweight materials with specific properties.
Wow.
And they're collaborating with pharmaceutical companies on drug discovery and development, even working on improving energy storage solutions like better batteries.
That's amazing. And it sounds like those are all areas where you really need that deep understanding of physics and chemistry that those LQMs can provide.
Absolutely. Yeah. You can't just brute force your way through those problems. You need to understand the underlying science.
So physical AI is really about creating AI that understands the world in a way that's similar to how humans understand it, right?
Yeah, exactly. Yeah, it's about learning from real-world data, understanding the fundamental principles of science,
Right.
and then using that knowledge to control and improve physical systems.
So how does Sandbox AQ actually operate as a business? I mean, do they build quantum computers?
No, they don't actually build the quantum computers themselves.
Okay.
Right now, the business models in the quantum computing space are mostly focused on research and development contracts
Okay.
with companies that want to explore the technology and also providing access to quantum computing hardware for research labs, often through cloud platforms.
I see, I see.
Fernando makes a really good point that most companies don't need to go out and buy their own quantum computer right now,
Right.
given the current state of the technology and the availability of cloud access.
Yeah, it's kind of like the early days of the internet, right? Nobody needed to buy their own server. They could just access it through a service provider.
Exactly. Yeah, it's a very similar situation with quantum computing right now.
So what's the point of all these partnerships then? If nobody's actually using quantum computers in their day-to-day business, why are companies willing to pay for access?
It's all about gaining knowledge, experimenting, and positioning themselves to be early adopters of a potentially game-changing technology.
Right, right. So it's kind of like getting a head start on the competition.
Exactly. And Sandbox AQ's advice is very clear. Don't rush out and buy a quantum computer today,
Okay.
but definitely invest in building a team with the expertise to experiment via the cloud and really understand what this technology can do.
I see, I see.
And, Sandbox AQ is really focused on those other areas of quantum technologies that are already delivering value today.
Like that.
So things like advanced quantum sensors. These sensors have unprecedented precision.
Correct.
Quantum simulation for designing new materials and molecules.
Right.
And also quantum-safe cryptography and cybersecurity solutions to protect against those future quantum attacks.
Right, right. Because those are real threats that we need to be prepared for.
Absolutely. And they've actually structured their company into 4 different business units, each one focused on one of these key areas.
Wow. So they're really covering all the bases.
Yeah. And they're also very committed to education. They have a YouTube channel with all sorts of content.
Oh, that's cool.
From short explainers to really in-depth discussions with experts, like they have this one with Jack Hadry and Eric Schmidt talking about the synergy between LQMs and AI quantum technologies.
Okay, I'll have to check that out.
Yeah, it's definitely worth a watch.
So let's talk about this whole quantum computing and cybersecurity issue, because that's a big one, right?
Oh, yeah, absolutely.
I mean, the idea that quantum computers could break our current encryption methods is pretty scary.
It is, yeah. And, the theoretical possibility of quantum computers has been around for decades.
Right.
But it was Peter Shor's algorithm back in 1994 that really raised the alarm bells. This algorithm, if you could run it on a powerful enough quantum computer, could crack the public key encryption that we use for pretty much everything online today.
Wow. And with the rapid advancements in quantum computing that we've seen in the last few years, it seems like that threat is becoming more and more real.
Yeah, a lot of experts think that we could have those kinds of quantum computers within the next 5 to 7 years,
Yeah.
around that 2029, 2030 timeframe that we talked about earlier.
So what are the implications of that? I mean, what's the worst case scenario here?
Well, Fernando talks about this store now, decrypt later scenario.
Store now, decrypt later. What is
Okay,
it?
so basically, nation states or sophisticated hackers are collecting vast amounts of encrypted data today,
Right.
with the expectation that they'll be able to decrypt it in the future once they have access to these powerful quantum computers.
So even data from the past could be vulnerable.
Exactly. Yeah, it's a really serious threat that we need to be taking steps to address right now.
So what can we do about it?
Well, the challenge is that most organizations don't even have a good understanding of their own encryption infrastructure.
Right.
And migrating to post-quantum cryptography, which means adopting new quantum-resistant algorithms, that's a really complex and time-consuming process.
So it's not just like installing a software update.
No, it's much more involved than that. It can take years, depending on the size and complexity of the organization.
And the US government is taking this seriously, right? I mean, they've mandated that all Department of Defense agencies have to have a plan in place to migrate to post-quantum cryptography.
Yeah, they're definitely taking it seriously. It's a top priority for national security.
And it makes you wonder what's going on in other countries, right? I mean, especially China. They've been making a lot of progress in quantum computing.
Yeah, Fernando frames it as a global race, kind of like the space race of the 20th century,
Right.
with both Western countries and China making advancements and trying to stay ahead of each other.
And it's like a secret race in a way because nobody wants to reveal their hand, right? If you've got a breakthrough in decryption capabilities, you probably want to keep that quiet.
Exactly. It's a very strategic area, so the true state of affairs might be a bit murky.
It makes you think about that whole Enigma code situation in World War II, right?
Yeah, that's a great analogy. The side that could secretly decrypt their enemy's communications had a huge advantage.
Exactly. And it could be the same with quantum computing. The nation or organization that has a powerful quantum computer and the ability to decrypt everyone else's secrets.
Right. It would be a very powerful position to be in.
Okay, so let's shift gears a little bit and talk about some of the more speculative but exciting possibilities, like potential breakthroughs and discoveries.
Okay, yeah, let's get into that.
Fernando mentioned Sandbox AQ's work on magnetic navigation, like a backup system for GPS in case GPS goes down.
Right.
And they're also doing research on advanced cryptography.
Yeah, lots of interesting stuff going on there.
And it's easy to get caught up in all the sci-fi scenarios, right? Like AI and quantum computing leading to all these amazing discoveries.
Yeah, and that ties into what you were talking about earlier, those aha moments, those sudden flashes of insight.
Right, right. Like those breakthroughs that completely change our understanding of the world.
Exactly. And, the combination of AI's analytical power and quantum computing's ability to tackle these incredibly complex calculations, it really has the potential to accelerate scientific discovery in all sorts of fields. Everything from developing new medicines to understanding the fundamental laws of the universe.
And that kind of leads us to the big question, right? The one that everybody's talking
The
about.
singularity.
Yeah, or artificial superintelligence, What happens when AI becomes smarter than humans? Is that something that could actually happen? And if so, is it something that we should be afraid of?
It's definitely a hot topic, and Fernando acknowledges that even defining what we mean by artificial general intelligence, AGI, and superintelligence, it's not straightforward. There's no universally agreed upon definition. But generally speaking, AGI would be AI that can perform any intellectual task that a human can.
Right.
And superintelligence would be AI that surpasses human intelligence across the board.
So it's that transition from AGI to superintelligence, that's where things could get really interesting, right?
Yeah, that's the point where AI potentially goes beyond anything that we can even imagine.
And some people think that quantum computers might be the key to making that happen, right? That they'll provide the raw computing power that AI needs to reach that level.
It's definitely a possibility, but Sandbox AQ's focus is really on the more immediate positive impacts that these technologies can have.
Right.
They're working on things like protecting sensitive information, creating advanced medical devices,
Okay.
like they're collaborating with Nobel laureate Stanley Prusiner on Alzheimer's research.
Yeah.
They're using LQMs to speed up the simulations of those complex molecules, trying to understand how the disease works. They're also working on improving navigation systems,
Hmm.
making them more resilient and developing sustainable solutions, like designing catalysts that can break down plastics.
That's great. And it seems like that focus on creating a positive impact is something that really attracts top talent to companies like Sandbox AQ.
Absolutely. People want to work on things that are going to make a difference in the world.
Yeah, they want to be part of something bigger than themselves.
Exactly. And Fernando emphasizes that Sandbox AQ's belief is that the convergence of AI, quantum technologies, and those large quantitative models, it offers a more hopeful and impactful path forward.
Right.
Focusing on solving those big human challenges
Hmm.
rather than just worrying about the potential risks of superintelligence.
It's like he's saying, let's use these tools to make the world a better place, right?
Yeah, exactly. Let's focus on the good that we can do right now.
He also draws a parallel to the internet, right?
Right. The internet has its downsides, obviously,
Sure.
but overall, it's brought a lot of positive things to humanity.
Yeah, I think that's a fair assessment.
And I think the same could be said for AI and quantum computing. There are risks, but there's also tremendous potential for good.
And what about those big questions about the universe? The things that have always fascinated humans, like the nature of black holes or the possibility of faster than light travel.
Right. Well, those are definitely big questions. And AI and quantum computing are powerful tools that could help us answer them.
Yeah.
The ability to perform these complex simulations and analyze massive amounts of data, it's going to be essential for scientific discovery.
Right?
But the universe is vast, and those questions are deep, so it might be a while before we have definitive answers.
Yeah, those are like those really long-term research projects, right?
Exactly. It's going to take time and patience.
And it seems like there's still so much that we don't even know about quantum physics itself, right? I mean, those experiments they're doing on superposition and entanglement, just mind-boggling.
Absolutely. Yeah, we're still learning about the fundamental nature of reality.
And Fernando makes this really interesting point that human intelligence, as amazing as it is, it might have its limits.
Right.
And AI, especially when it's combined with the power of quantum computers, that could be the key to pushing past those limits, to expanding our knowledge in ways that we can't even imagine right now.
Yeah, it's really exciting to think about what we might be able to achieve with these tools in the years to come.
So wrapping things up, it's clear that AI and quantum computing, they're not just science fiction anymore.
No, they're very real, and they're going to have a profound impact on our world.
They have the potential to change everything from how we do business to how we understand the universe itself.
Absolutely. And it's
Yeah.
something that everyone should be paying attention to, even if you're not a scientist or an engineer.
Yeah, it's going to affect all of us in one way or another.
And for those who want to learn more, I highly recommend checking out Sandbox AQ's YouTube channel and their website. They have tons of great information and resources.
Okay, we'll put those links in the show notes.
And they also have partnerships with universities and residency programs. So if you're interested in getting involved in this field, that's a great place to start.
Yeah, there are so many opportunities out there for people who want to get involved in this exciting field.
Absolutely. And the pace of discovery is only accelerating, so who knows what the future holds.
That's the most exciting part, right?
Mhm.
We're just at the beginning of this journey, and the possibilities are endless.
Yeah, it's going to be an amazing ride, that's for sure.
So thanks for joining us on this deep dive into the world of quantum computing and AI, and until next time, keep exploring.
Keep those brains firing.
Exactly.
And we'll see you on the next deep dive.
All right, see you later.
Take care.